Oh, I'm going to do this one, right? Okay, can you hear me okay? I know you probably can't see me. Sorry about that. I'm so honored and excited to be here today, and I do apologize for my compromised circumstances. And I know it could be a little awkward because I'm supposed to be your tour guide and translator today, and some of you may not be able to see me. But I know that we can do it because we are a room full of people who step up. So we're just going to step up today, and we're going to get this done. What I want to do is give you a handle on what is known, whether you have a lot of experience or you have none. And you should engage as much as you can. So if you're confused, talk to your neighbor. Raise your hand. Ask me to stop. Ask me to say something again. I want to make sure that we, even if we didn't get through all the slides, if we got through a chunk and people felt like they really had mastery of it, that would be great. So please feel free to interrupt me. And the other thing is, you know, this is one of those things where we're all here to really make a difference, and it's time to just lean in. So there's going to be some times where I put something up and it looks a little overwhelming. Just lean in a little closer, and we'll figure it out, okay? So let's see. This is going to advance my slides, and it's nice to see so many familiar faces out there too. All right, so this is what we're going to do today. We're going to talk about what is meant in this literature by stress, what that means to the researchers who do this kind of work, and what its effects are on the body. We're going to talk, of course, about the special case of early development, because that's why we're all here today. I'm going to tell you a little bit about the idea of toxic stress and sort of how that's defined and where that sits, the types of evidence we have so far, and the types of evidence that we need, so that you can be aware of that as we move forward. I've been asked to comment a little bit on risk and resilience, which is something that always comes to mind when we talk about early adversity. And then we're going to talk a little bit about intergenerational effects. I know a lot of people have heard the term epigenetic, and maybe would like to know what that means. So we're going to talk a little bit about that today, and what the implications of it might be, of that research might be for this particular topic, okay? So hopefully that will be a big enough bite and not too big. Okay, so there's no reason why anybody in this room can't get through this. So if you're a total science math phobe, no problem, okay? So don't feel like this doesn't apply to you. That's the whole point of this, is to make this accessible to everybody. Okay, so what we mean when we talk about physiologic stress is we actually mean what your body does in response to an event or challenge. So the easiest way to remember that is to think about, okay, what happens when you get sick? So let's say you have strep throat. What do you feel? What are your symptoms? Fever, right. Okay, so what causes that? Actually, it's your own body trying to control the strep, okay? So the fever is your body's response. Bring your body temperature up, cook the bad things, that's good, right? Almost all of the symptoms you feel when you're sick are actually your body handling the problem. And so it's tempting, we think of those as the sickness things, even sickness behavior, that idea that I'm just going to lay around, I feel terrible, I'm not going to do anything. That's good when you're sick, right? So all of those things that you feel are actually your body helping you handle this challenge. You can't feel the virus. You can't feel the bacteria. So this is very similar to that. So this is a situation where what we're talking about is all the things you feel when a stressor happens. And just like with your immune response, there's both good and bad things to the way that your body handles stress, okay? It's good because it gets you through the situation. You want a fever, it's going to cook those bad things, great. But it makes you feel bad, and over time it has consequences. The same is true for stress. So you need to have all of those things happen in your body, but if it happens a lot, all the time, over time, that is what takes the toll on you. So all of this literature is focused on defining stress as what your body does in response to a challenge. One of the things I really like about that is it takes away sort of the individual differences and perceptions and all of those other things that matter. So an event might be stressful for you and it might not be stressful for someone else. I don't care about that. What I care is, what is your body doing, okay? So if your body is reacting, then I'm interested. So it kind of gives you a little bit of an even playing field. And when your body reacts because you need it. And you need it because the challenge and the resources you have available are mismatched, okay? So sometimes you can think of probably situations where in a really bad situation, but you've got this, village of support. So you don't feel that bad. You're like, this is pretty terrible, but look at all this support I have. Versus situations that might be actually relatively minor, like say the tow truck takes your car. It's not, not life-threatening, but, if your whole family is out of town and, all your friends are occupied and you're going to have to, you have no way to get the car, it now turns into this huge thing, right? So you can see how both of those things might happen. So what we're interested in is when your body kicks in, okay? Why does that happen? And it's also really nice when we're talking about young children because they're not very good at telling us how they feel and when they're stressed, and they often give sort of referred, I have a headache or something, I have a stomach ache. They know something's wrong, but they don't know how to tell you what it is, or maybe their behavior is just sort of erratic, that kind of thing. So having physiologic indicators is really nice because it gives us that piece of information that, okay, this body, this organism has turned on to deal with this situation. And I don't have to worry about whether I think it's something they should be stressed about. Okay, so how does it work? So the classic, oops, I'm advancing mine and not yours. Okay, so the classic example is always a tiger in the room, which I think is ridiculous. I mean, how does that relate to anything? So I'm gonna actually tell you about my accident because I think that will help you be in the present moment and you won't have to wonder why my leg is like this. But what I'm gonna tell you about is the cascade that happens between the stressor occurring, it being perceived by your brain turning on a whole cascade of responses, what that looks like in your body, and then the long-term outcome that we care about is your long-term physical and mental health. So that's that guy at the end there with his heart being monitored, okay? So my accident. So I went over a cliff in my car, slid off the road on a pretty major cliff, went down 40 feet embankment and crashed into some trees. That part all happened really fast, as you can imagine. And then, hit the trees, and there's smoke, coming out of the car. And I'm down this super, super steep embankment, and I'm thinking, nobody is going to find me down here, right? Because how are they going to see me? Plus, it's snowing, so my tracks will get covered, right? And they won't know I'm here. And I have a 7-month-old. So I'm like, I got to get out of this car. I have a baby, I don't really have a choice, right? So, okay. Good news, my stress systems are going to go way up, right? This is great because it turned out I have a broken leg in a few places. I couldn't feel it. Who cares about my leg? I mean, the big picture, right? It doesn't matter. I got to get out of here. So I don't really feel the leg. I mean, I several times told them I wasn't injured. I didn't need an ambulance. I was like, oh, no, I'm fine. And then, but my attention is super focused on the problem. It was -8 degrees. I'm not cold. Right? So in this window of time between recognizing that I have to get out of the car and getting the first person to help me, I have all of this stuff ramped way up, okay? So then a plow truck guy backs up and goes, oh, I wondered where those tracks went. You're down there. Yeah, sure enough, here I am. And then right then, it's like, whew, this is going to be fine. He'll get help. I'm going to be able to get out of here. It's going to be fine. Then what happens? I'm cold. My leg hurts, right? Which is okay because now I can attend to those problems, right? Now I could have continued to keep that vigilance up. I could have done that. I could have done it all the way to the hospital. I could have done it for 4 days in the hospital. And some people do. Some people have a very hard time down-regulating. The ambulance actually broke on the way to the hospital, which I thought was really funny because at that point, I'm warm, I'm in the, what does it matter? It's fine. Whereas in another situation, if I had been rushing to the hospital, that would have been catastrophic. So, okay, so the point is, what you want to do, you want it on. When you need it, okay? This is good stuff. You want it in this kind of situation, and you want it for exactly as long as you need it. And then that's it. Because it's going to trump everything else. And you have a lot of other things to do, especially if you're a little kid. You got to grow and learn and, interact with people. You can't be monitoring for stress all the time. That's not going to work. So, all right, so what happens is the tiger enters the room or your car goes over a cliff. A cascade is initiated in the brain to manage threat. And what I just mentioned is, at least for humans, oh, sorry, my dad's telling me to advance the thing. At least for humans, what makes this difficult is that we are really good at turning our stress systems on when nothing is happening, okay? We're driving to work and we're thinking about a conflict, okay? There's no present danger. Nothing is happening. And the more you do that, as you know, rumination, that's all components of difficult mental health situation, right? So you don't want to be doing that. You want to be a zebra. Apparently zebras don't do this. I don't know how they figure that out. But if you're really interested in this topic, this is a great book to have around, or if you want to be able to give something to people, Why Zebras Don't Get Ulcers. I think there's a 3rd edition now. It's a really good translation of all this stuff that I'm going to tell you today if you want to continue. Okay, so yeah, so we are really good at turning these systems on, unfortunately, which is not great. So here we are. Here's our tiger, or me, going over the cliff. Stress onset, bump it up fast. You want that to work, okay? And then as soon as the stressor goes away, so the tow truck guy turns up, or you have some other active coping mechanism that you can engage. So you decide, you know, I don't know, say my cell phone worked, which of course it didn't. But, you know, say something like that became available. That would be the time to shut it off, okay? So as soon as you have a solution, even if it's not there yet. And then you want to recover. You want to come all the way back to baseline. So in a situation with a normal, healthy situation, we do this, you know, relatively often, up and then down, up and then down. And you can probably think of situations where that's happened to you. Now, how does it work? Physiologic stress is largely about energy. The easiest thing to think about is just to remember this: you need a ton of energy in this kind of situation. You need all of your energy focused on this problem. It's metabolically very costly to handle a threat, okay? So whether you're going to fight, you're going to flee, whatever you're going to do. So you take all your energy from everything long-term, like digestion, reproduction, growth, repair, long-term immune processes. I don't need to be making flu antibodies while I'm on the side of the cliff, right? Not so much. No, I need to be not having my leg get so inflamed that I can't move. So one of the things that this system does is impair inflammation, slows it down. And I need my respiration up. I need all the glucose that's floating around in my body available to burn, and I need reserves to be pulled, so that if this goes on for a couple hours, I'm going to be able to handle it. I need to be able to move my muscles. I didn't put on here pain reduction, but that actually was really helpful in this case. So there are some natural opiates that you can, you know, induce in stressful situations. So all of this is what is happening. Question? Behind the slide, thank you. Oh boy. I can't see that, that's the problem. So just say behind. All right, okay. All right, so I'll try to do this one first. All right, so there's 2 big stress response systems, and they're likely activated at the same time, both a primary and a secondary response to help manage threat. And the one you're probably actually more familiar with is the NESAM system. That's the one where your heart rate goes up and your respiration goes up, and that's the classic sort of fight or flight mechanism that you probably learned about in school. We're actually not going to talk too much about that system today. What we're going to talk about is the second response system, the hypothalamic pituitary adrenal axis, because that's the system that produces the hormone cortisol that we are very interested in the context of toxic stress. Which is not to say that there aren't a million interesting things about the NESAM system and lots of interesting research on that topic, but we're going to focus on the second response system today. And we call it the second response system because it's slower to have its effects, even though it starts about the same time. And it does replenish those glucose stores that the NESAM system burns through. And one of the classic markers of having chronic stress exposure is having fat deposits around the midline, having a sort of a tire around the midline. And the reason that that happens is, where's a good place to store your energy if you're going to need it all the time? Right in the middle, right? And what's the best energy storing thing we have? Fat. So it is serving a purpose there, but it then is putting you at risk for heart disease and all the other things that we know are bad about having midline adiposity. So it's always going to be this case. It's going to have a reason, and it's going to have a consequence that we care about. And it's just the way it goes. All right, so this is the scary slide. And this is just showing you what the cascade is. And the only reason this matters is that we are only measuring the downstream product of a very complicated system. And there are a lot of other things that can be measured and could be understood that could be important. So one thing I want to point out to you, so the reason it's called the HPA axis is that the first signal starts in the hypothalamus, up in the top there, and then it travels to the anterior pituitary, which is at the base of the brain, and then the ACTH travels through the bloodstream to the adrenal glands, which sit on top of the kidneys, and those produce cortisol, among many other things. And then cortisol goes everywhere it feels like in your body. The important thing about this figure is the yellow line that goes back up. Cortisol serves as a shut-off device. So it tells your body, okay, I got the signal. So one of the things that happens in chronic stress situations is that feedback gets broken. So you activate the system so much that the receptors get worn out, and then you don't get the feedback that says, I got the signal. So then you have this forward feeding cascade, okay? So that's why I wanted to show this, even though it's a little bit of a scary picture. Okay. The HPA axis is highly conserved. We share it with salmon. So that means it's at least 400 million years old. So the chances are pretty good that it's not there by accident, right? So, I mean, we don't share a lot with salmon, right? So I'd just like to point that out to remind you that it's busy, it's got a lot of jobs, and a lot of what it does is super important for us. It is a potent steroid hormone, and like all steroid hormones, that means it can cross the blood-brain barrier, so it can travel between the brain and body without a problem. And it it is invited into cells because cells have hundreds of thousands of receptors for it. So it can go into all the cells of the body, it can go everywhere it wants. Next slide. There it is, thank you. And if you don't believe me, think about what you do if you get a bug bite. What do? Really super itchy. What do you put on it? Cortisone cream, because it reduces inflammation. Okay? What about if you have one of those chronic shoulder injuries? What do you get? Cortisone shot. What if you have asthma? Inhaled steroid, right? Because it works. It works. Okay? But it has, a lot of other things that it's busy doing too. So we're going to focus on what it does about stress and challenge, but we have to remember that it has all of these other consequences in the body, and a lot of it is going to be about energy and control of the immune system. So when you're looking for outcomes and you're looking for things to be concerned about for kids, you're going to be looking for things like growth and health, because those are the other things that this system is busy doing. Okay, so we know, for example, that kids who have been in extremely adverse circumstances are small. They're quite small, right? Okay. Everybody still with me? Great. Okay, so what we want to know is, when is physiologic stress adaptive, helpful, necessary, versus when is it maladaptive, costly, and leading to physical and mental illness? And that's going to be a different line for everybody. There's not going to be a single right answer to that question. A useful way to think about it is this term allostasis and allostatic load, which you'll come across a lot if you dive into this literature at all. So this is reconceptualizing the idea of stress as an issue of balance. And allostasis is like maintaining homeostasis, like keeping the temperature in your house kind of even. It's like that, except you're maintaining a set point that changes. Whereas in your house, you maybe want to keep it at 68 or whatever you want to keep it at. So we talked about this on when you need it, off when you don't. And ideally, you would activate these systems, relatively infrequently, right? Because they're super energy consuming. Only for true threat situations. So not when something is not happening to you, and you would want to return quickly to baseline. So what happens when that isn't true is called allostatic load. That's the wear and tear of the stress systems over the lifetime. And that can accrue much earlier for people who have much earlier intensive stress experiences, or it might accrue later in the lifespan for people who have less frequent stress exposure. Okay? All right. Okay, so there's two ways things can go wrong. The way we want it to work is on the left. Nice bump up and then straight back down. Nice recovery, say maybe 40 minutes total. The two ways that it can go wrong on the top is probably the one you're more familiar with and probably the one that you will hear about more because it's a little bit easier to wrap your head around. That's when every time something happens, you overreact. Okay, so you've got a system that is, your just set point is high. You're jumpy, you react to everything, you know, and you don't come back down very easily. Okay, so maybe you're like that, maybe you know people who are like that. That's one way that things can go wrong. That's a lack of adaptation to a stressful situation. The other way that things can go wrong is you just turn it off. I think of that as physiologic learned helplessness, and that's actually the more concerning of the two cases. Okay, because in the one case you have a highly reactive system, but you can train the individual then, right, with behavioral techniques to reevaluate the situation, think it over. What do you do with the person who just doesn't turn it on at all? And it was, you know, previously thought that that was pretty uncommon. I'm going to show you, I think, I don't know if actually my slides, which slides are loaded here, but if they're not up there, I'll tell you. We have data with about 18% of kids in some of our samples in Colorado showing this flat pattern. So they're just not reacting. Now, there are, you know, a number of reasons that could be the case, but it's probably not a great sign, right? It probably means that they've gone through a lot already, and they've just decided that it's sort of not worth it. It's not going to work. Maybe, and we actually think it might be true, that at puberty you might then see a switch to a highly reactive profile at a time in terms of your body and your own, in our evolutionary history, that's the time where you change your group, right? You take responsibility for where you are and move to a different group. And so at puberty, often there's a lot of change in all kinds of hormone systems, obviously. So we're really watching this low profile, in addition, of course, to the kids who are highly reactive. Okay, and then just to remember, we do want some stress, right? I mean, we don't want to all, even though we're in Colorado, we don't want to all just lay around and do nothing, right? We want to get stuff done, and we want our kids to be challenged, and we want them to grow and develop and do all the things they need to do. So you're looking for this sort of sweet spot. And you probably have a sense of what that sweet spot is. You know when you're in, if you play sports, or you know when you're in it, when you're just, you know, you're activated, you're in the game, you're ready to go, but you're not overwhelmed, you're not worrying, you're just kind of right in that sweet spot. So that's what we're aiming for. So for example, these are data from a study where kids had a mild stressor, and the kids who had a bigger court response to the mild stressor had better memory for the event. Okay? So, you know, this is a mild stressor. If you get a severe stressor, your memory goes totally out the window, as you know if you've been in any kind of traumatic situation. Okay, and then timing, of course, is everything, right? Timing is always going to be critical. And it's going to be a question of load, right? How many things can you take? I would say it's my anecdotal observation that when stressors cross domains, it's worse than if they're all in one domain. So say you have a really super stressful job and there's all kinds of things that are stressful about it, but everything is great with your health and your family and your love life and financially everything's fine. That's going to be easier to handle than you've got stress at work, you've got a sick relative, you're having relationship problems because your whole system is kind of out of balance there. All right. Okay, so there are great data, correlational and longitudinal data, suggesting a strong link between stress across the lifetime and health. What does that mean? What's correlational and longitudinal data? It means that we ask people, sometimes we ask adults about their early life experiences, and then we take measures of their current health and we go, whoa, the people who had the hard lives earlier, you know, they aren't doing so well. Now, that's not proof, right? That's not proof. There's all kinds of other things that could have caused that. But there are a lot of these studies. So it certainly looks like there's a link. That doesn't tell you how it happens. It just tells you that there's, something going on there. The link is highly related to SES, which is just socioeconomic status, which is a combination of income and education, usually. Income, education, sometimes status, like what is the status of your profession is considered. So low SES individuals are at a much greater risk for stress-related disease. What's interesting about this, though, is this is true. It's not due simply to things like healthcare or behaviors like smoking more, that kind of thing, because you can control for those things statistically. You can also do this kind of study in a country where they have universal health care, and this relationship still holds. And in some cases, perceived low status is the most important thing. So being the person who has no resources in a high resource environment, rather than having the same resources but being in a community where you're relatively average. So you can't afford to buy milk in your community, So perceived social status can be really important, and that's an interesting one because that's something that can be changed, right? That's something you could work on. Okay. So chronic stress influences your susceptibility to, so whether you get, but also the progression of so many diseases, it's kind of crazy. I mean, we really should be routinely asked about stress when we are evaluated for any medical condition because it has such a big impact on how you got there and what's going to happen next. Big hitters are things like cardiovascular disease, diabetes, and infectious illness. So I don't know, who's had the experience of having, say, a really stressful period of time and then going on vacation and getting sick? Right? I mean, how irritating, right? But you have been using your stress systems, and they have been up, and they have been doing their job, and then you turn them off, and now you got to pay the price. So it's not an accident that happens, right? So knowing, I don't know how much you can do about that, but certainly trying to control your stress exposure is worth considering. Okay, it also increases the risk for obesity, like I already mentioned, for useful reasons. Decreased immune function, because that's one of its jobs, is to help you focus on the current situation. And impairing growth, again, because one of its jobs is to take energy. It can impair cognitive functioning, including attention and memory, which is difficult, right? Because that's going to feed forward into the same, making it hard for you to handle then the next challenge. And these are all things that have been well documented. So chronic stress is well documented to have associations with all of these things that I'm talking about. Okay, and then not surprisingly, increased risk for mental health problems, specifically depression and anxiety. But also some, that have a very high explanations in other domains. So like schizophrenia can also be very impacted by stress exposure. Okay. So the effect of stress can depend on many factors. The type of stressor, the duration. We talk a lot about acute versus chronic, so where chronic is going to be the problem. The unpredictability or uncontrollability of the stress. So if you can think of situations where you might have a very stressful thing going on, but you're in control of it, how different that feels than a situation where you have no control of it. And then think about your average 3-year-old. They have control over pretty much nothing. So it all kind of feels, why do we tell them, like, in 5 minutes, we're going to do this? Why do we do all that stuff? Because it gives them some sense of control over what's happening, right? So otherwise, they have just this, they have no idea. Any adult can come in, basically, and tell them anything or make them do anything. They're not in charge. The social environment of the stressed individual is very important. Caregivers for children and social support for adults. And it isn't just the number of people, it's the quality of the support that you have. And it's also really important. Sometimes people who have a big social network actually suffer because they're taking care of all of those people. So it isn't as much support as it might otherwise be, right? It's actually a stress. And then the timing of the stress, we do think early life stress may be the most impactful time. And a lot of that makes sense because the child has some degrees of freedom in terms of how their body is going to be organized, what their priorities are going to be. And this is telling them what the world is like. This is what my world is going to be like. And so, you know what? I don't need to be as tall as I could be. I don't need to be, you know, I don't know, another example, but what I do need to be is vigilant. What I do need to be is on my game. Uh-huh.
When you say early life?
Mm-hmm. So I would probably go at least to 5, and I would certainly include the prenatal period. I think things start to settle down a little bit between 4 and 6, depending on the individual child. I've still seen some pretty bouncy 6-year-olds, but they're usually 6-year-olds who have other immaturities. Okay, and then genetic risk factors, which a lot of people are working on trying to understand, because like every other genetic risk factor, it's more information if you know that that's what you're working with. All right, yes? Oh, no problem. Yes, yes, special needs, and I have done some studies with special needs kids, and they tend to have what we might otherwise think of as physiologically impossibly high levels. And it can be over, especially we've worked with some kids with autism, it can be over something that seems very minor to the adults. So some small perturbation of their environment that's not what they're used to is a major, major stressor, and they're feeling it, and they're feeling the consequences of it. So yeah, that's a great point, thank you. Okay, we're gonna switch to the next thing if everybody's good. Yes? Okay. All right, the special case of early development. I have these 3 guys up here because I am going to remind you frequently that a lot of the work that has been done in animal models, which means it's been done with these cute little baby rats, and some work with primates, non-human primates, and then some work with humans. But because you would not assign a child to a stressful circumstance on purpose, some of this work is done with animals. And I know a lot of people feel very uncomfortable about deliberately stressing animals. And I think, you know, there's a lot to that. So I just wanted to point out that is where a lot of our knowledge base comes from. Okay, so what's different during development? One big thing is your stress systems are developing. They're figuring out what they're going to do. Like I was just mentioning, they've got that wiggle room. And it's like all kinds of plasticity that we have as humans. We come, you know, we're born as these hopeless, helpless little creatures, right? But that gives us the opportunity to become so many more things than if we were born in a more mature state. So this is just one of those examples. You have the opportunity to make some choices about how you're going to be organized. So a really good example of that is very stressed pregnancies are much more likely to have early preterm birth, right? Why? It's stressful in here. I'm going to get out. So in order to get out, what do you have to do? Your brain has to mature a little faster. Compromises have to be made, okay? So you're going to be a little smaller. You might even be small for date, but you're out of that toxic environment, okay? So that's the first example of making a choice, right? I mean, obviously it's not a cognitive choice, but making a choice about how you're going to develop in order to survive, okay? And that's going to continue across the first few years of life for sure, that their brains and bodies are making choices about how they can maximally survive. And that isn't going to be good for every possible career trajectory and every possible health outcome, right? But it might get them through the short term. Okay, their behavioral responses are super limited. So what are effective things people do when they're stressed? Remove yourself. That's a great one. Yeah? Anybody else? Sleep. Yeah. Yeah. Eat. Plan, right? You plan, like, okay, I know I'm going to have a rough afternoon, so I'm going to, try to take it a little easy this morning. They definitely do that, right? Little kids? I mean, they just go full steam until they hit the wall. And they can't ask for help in the same way, right? They don't know how to ask for help in the same way. Sometimes they ask for help in ways that are aversive to adults. Dissociate, yep. Yep, they throw tantrums, right, and things that then cause adults to act negatively toward them, which isn't going to help. So they don't have a lot of options. And that's something we can really work on. We can work on teaching them those options, right? We try to teach them those options and try to help them recognize what they're feeling in their body and slow down a little bit. Those are things we can help them with. And then the third one is they're completely dependent on us, even if we're the problem. So, and nothing is going to change that, right? No kid is ever going to say they want to leave their family. Nothing is going to change that. What can we change? We can take a 2-generation approach, because they're dependent on those folks. And that's a great option. I know it isn't always possible, but that's where a lot of our effort is focused right now. So physiologic stress itself and normative stress physiology looks different in children. They have different levels, they have different patterns, they do different stuff, they sleep in the middle of the day. So you can't translate directly from adult work to child work. You actually have to take the time to do the baseline work in kids. And that's, not very sexy, but it does have to be done. And so, we're getting there. We're getting a body of knowledge together about how kids respond in typical situations so that we can understand how they respond in atypical situations. So if you search for me on the internet, you may come across, I've done a lot of work about stress in the context of childcare. So just normal kids in childcare showing a reaction across the day. I do that work because I'm an early childhood person, and I firmly believe in early childhood education, and better me than somebody who thinks, women should stay home with their kids. But also because, okay, that's what the system can do in a relatively mild situation. So let's get that on the table so we understand what we're talking about when we are talking about kids who are in neglect and abuse situations. And that actually is the road that led me toward recognizing these kids who have this non-reactive, super low cortisol pattern. I would not have thought of that. I would not have gotten there if I hadn't done that other work first. All right, this is another complicated figure, but most of us have been around in the couple of decades where there's been a lot of focus in trying to figure out how does a particular stressor lead to a particular outcome. So people who have been sexually abused, what happens to them? People who have been physically abused, what happens to them? That doesn't actually make a lot of sense. What makes sense is when did the thing happen, not what happened. When did it happen and what was busy developing? So if you think about it that way, okay, it happened in the prenatal period. What was happening then? Those are the things that are going to be compromised. And that's why all of that literature is a mess, right? You get in there and you're like, well, it's sort of like it, for some people, if they were sexually abused, it's this, but only if they were also physically. It makes no sense. It makes no sense because timing is the critical issue. And some really important time periods to consider are the prenatal period, the immediate postnatal period. Adolescence is a really busy time. Across adulthood is a full window, and then again, stress and aging. So there's very different priorities, biological priorities during those developmental windows, and you're going to see different effects on the brain and body based on the timing. So this is the way that most of my colleagues currently think about what kinds of effects to look for, okay? Okay. All right, so I'm going to just give you some prenatal stuff. It's actually called programming, fetal programming. That's what this work is called, because that's how people who study this think of it. So the fetus is getting programmed to understand what is coming. It's also sometimes called the Barker hypothesis, the idea that your adulthood health state is determined or highly influenced by your prenatal environment. So you may encounter that terminology. So as you probably know, the human fetus is growing incredibly rapidly, 8 times more cell divisions before term compared with cell divisions during the remainder of life. Oh, that little thing is not going to play probably. That's just cells dividing on the bottom, just how fast it happens. Okay, so that's been described as programming. So by 7 weeks gestation, cells in the brain have begun touching and forming their primitive nerve paths already. And by 7 weeks, not everybody even knows they're pregnant, right? Over 100,000 nerve cells per minute are growing at this time. I mean, that's just crazy. Like, how is that even possible? It's crazy. And at birth, the baby will have 100 billion nerve cells. Okay, that's more than they need, actually. There's all kinds of things happening. So they're growing, they're migrating to where they go, they're differentiating, they're connecting to each other. And then myelination continues. I'll tell you about all of that in a second. So the connections first start out with everything kind of connected to everything else. Like, it would be like, those of you, who has a smartphone? Does everyone have a smartphone mostly? Okay, did you notice the day that all of a sudden there were all these people in your contacts you don't know on your phone? Like, they come from where? The internet? I don't know. Who are these people? You know, that you sort of roughly know, or like, I don't know, are they from Facebook? Where are they coming from? I'm not going to call you, right? And they're all in your phone contacts. Okay, that is super not helpful, right? I want to call Kathy, right? I don't want to call, who are these 5 other Kathys? I don't know these people. So it's kind of like that. They start out with everything connected to everything else, and they kind of look like that, right? When they're first new babies, they sort of look like, whoa, you know, everything. This is a mess. And they have to figure out which thing goes to which thing, right? And so that's part of that process that's happening. You want the right things to get connected to the right things. So that's a really important process that is super influenced by the kinds of inputs that kids get. Are you talking to them? Are you saying to them? Are they getting tactile stimulation? Are they getting positive growth opportunities? Are they avoiding negative? That's all what's happening during that time. If what they're getting instead is they're mostly left alone if they're quiet, and then they're getting negative attention when they cry, which connections are they going to keep? So it's, you know, it's not a mystery how this happens. And myelination is a really interesting one. That makes your signals go quickly. It's just fat wrapped around the connections, just like insulation around a wire, and it makes the signals go quickly. In order to have good myelination, you have to have good nutrition. And it's the good fats that make that tissue. So breastfeeding is great for it, but also a diet high in healthy fats. Okay. And this is just showing you across the lifespan. So a lot of that is going to happen real early, and then we're going to have a sharp decrease and then kind of hold it relatively stable across the rest of the lifespan. Okay? It's not that you can't make new neurons, and of course you can make new synapses across life, but there's this crazy busy period in the beginning. Okay, birth phenotype, which usually just means birth weight, so how big are you and are you small for date, predicts disease in adulthood because it's your first indicator of what the fetal environment was like. It's your first birth indicator of what has already happened. So it's a really good way to tell if somebody is going to be at risk for coronary heart disease, hypertension, diabetes, all of these related illnesses. In addition to psychopathology, like autism, ADHD, schizophrenia, affective disorders. So just knowing how much a baby weighs and when they were born relative to when they were conceived tells you that much information. It gives you a pretty big idea of how important that time is, right? Okay, and these are data from a colleague of mine, Alicia Davis, who recently joined the faculty at DU, and she primarily studies prenatal stress, and she is working with Kaiser and Denver Health, I think, now on her new studies in this area. So these are data from her, and what you can see is this is basically just mapping mom's cortisol during pregnancy and baby's reactivity to their first stress exposure, which is the heel stick blood draw, which you guys have all experienced, which is not a stick, right? I mean, they squeeze the thing for like minutes. It's terrible. So the baby has both, you know, both babies have a reaction to that, as they should. But the blue line are the babies whose moms had extra high cortisol during pregnancy. Cortisol is high during pregnancy anyway, but they had extra high. Those kids don't come back down already at birth when they're getting their heel stick. Okay, so what have they learned? They have learned that they need to be vigilant. Okay, and then this is predicting the same thing, but predicting to problems at 6 to 8 years. But you are not seeing it. There you are. And this is things like clinging to adults, fears of going to school, nervous, high-strung, or tense, and the same relationship where you're seeing kids who were exposed to those high levels of anxiety and cortisol in utero being the same kids who have a lot of fears and worries themselves later. Okay? All right. And then this is pretty new, cool data they have. So that's a picture of the amygdala, the two amygdala in your brain. Your amygdala is the part of your brain that helps you detect fear, fearful stimuli, right? Know that something is scary and help you process that. It's a very important, tiny structure in the brain. And what they found is that kids who had higher maternal cortisol concentrations early in gestation had larger amygdala volume. So they had bigger amygdalas, got to watch for stuff, and more affective problems, so that's just emotional types of problems at 6 to 8 years of age. And the effect size was quite big in this particular study. Okay? Yep. Yeah, so like Randy Ross and folks study a lot of this related stuff, but working more on sensory gating and that kind of thing. And that's a really interesting one because it cuts across a number of disorders. Oh, sorry. The question was, what about I think you said sensory processing disorder, and I sort of flipped it to sensory gating, which is just the being able to control the flow of stimulus in your environment. So if you have poor sensory gating, if there was like say a loud beeping in here, you wouldn't be able to ignore it over time. If you have good sensory gating, the first time you'd be like, what was that? And then you just let it go. Okay, so having poor sensory gating is a risk factor for so many things. And you guys probably, a lot of you know kids who have that super sensitivity to environmental stimuli. So that's, there's some good data on maternal nutrition during pregnancy related to that, particularly choline. And choline is a building block for a lot of your neurotransmitters. And so not having enough choline in the prenatal period you don't have those building blocks that you need. And choline is in like eggs and that kind of thing. So, and it's not yet in all prenatal vitamins, although I've noticed increasingly it is included. But it's one of those things that's much better from food than it is from vitamins. Okay. Great question. All right, so did I convince you that early life is important? Okay. All right, because you needed to be convinced, right?
Explain a little more about what a larger
Sure, that's a great question. So, having a bigger chunk of tissue in your brain devoted to something, what does that mean in general? Okay, if you're a London taxi cab driver, you're going to have a really big part of your brain dedicated to navigation because you use it a lot. So you have a really big amygdala because you're anticipating monitoring for fearful and novel stimuli a lot. Does that mean that if you are the London cab driver and you stop driving a taxi, 10 years later, is that region still bigger? Probably not. So it doesn't mean it's deterministic and forever and this brain region is big and so it's going to be big forever. But it does mean that it's big to start off with because that's their expectation for what is coming. Okay? All right. So toxic stress. Toxic stress is a really interesting, this is a great example of somebody finally doing the thing we always say everybody should do, which is take the science and make it make sense to somebody, right? Make it make sense. So toxic stress is not a scientific concept. We use the concept early life stress because that's quantifiable, how much early life stress. What is toxic stress? That's not a scientific concept, but it is a great organizing concept. And actually, we're all in the process now of defining it more scientifically because it's so useful. This paper, if you can read it, gives the original sort of breakdown of how this concept is going to be defined. And Jack Shonkoff is a pediatrician, and Tom Boyce and Bruce McEwen are both very, very famous, very productive researchers in this area. So they kind of all sat down together and said, all right, what are we going to do about this? We're going to give it a label. We're going to get people organized. We're going to do something with all of this knowledge. And what's great about it is because they're real scientists and real practitioners, they were able to take knowledge from a bunch of different disciplines and coalesce it into one thing. And so, it's just been a really useful contribution. All right, so positive stress is what we've been talking about, the good stuff, right? So moderate, short-lived increases in heart rate, blood pressure, stress hormone levels, that's fine. things that might cause it to happen: dealing with frustration, receiving an immunization, getting really cold, other normative experiences that you might have in life. And the key thing to remember is that's an important aspect of healthy development. Okay, so it's important to have, every time your kids get stressed, don't freak out. Okay, it's good for them to learn how to manage stress. That's part of what they have to do. Because it's experienced in the context of stable and supportive relationships, then they have adaptive responses and they have good outcomes. And the adaptive response that they get with the support that they have brings their whole system back down to baseline, and then they're ready to handle the next challenge. Okay, so that's the good case. Tolerable stress. This is the physiologic state where this is, pretty bad. It could disrupt brain architecture, but it doesn't, because you have the support of these relationships that facilitate adaptive coping. So this could be something more serious, like the death or serious illness of a loved one, homelessness, or natural disaster. Key features are it occurs with a relatively time-limited period, or you have some control over it. Those two things could be true. But that you have protective relationships to help bring your body back into balance. Kids are happy to give things over to us, right? They don't want to worry about stuff. They're happy to let us do it. But they do it if we don't, right? So this is the situation where you trust the caregiver to take care of you. And then toxic stress is the situation where the stress is strong, frequent, and prolonged activation of your stress response systems, and you don't have the buffering protection of adult. Okay, so it often goes along with complex stressors like poverty, because poverty isn't a single stressor, it's a multidimensional stressor. Having a caregiver who's unavailable for a number of reasons, like they're incarcerated, like they have psychopathology themselves, like they have a substance abuse problem. So they're unavailable to you, or inconsistently available to you for any number of reasons. And then the key features of that are going to be this is expected to disrupt your brain architecture or change your brain architecture to match the environment you're in, right? It's just the learning machine. It affects your other organ systems, and it sets your stress management system either up or down regulated, like we've been talking about. And those changes, yeah. Mm-hmm. Mm-hmm. Right. Mm-hmm. Mm-hmm. Right, that's a great question. So the question is, what happens, it sounds like tolerable stress is acute and toxic stress is chronic, but you have caregivers in one and not the other. What happens if you have chronic stress, but you have these caregivers to look after you? I think then that's going to weigh in other things about the child, genetic risk, temperament, all those other things that are going to probably be factors. But in this taxonomy, the most important thing is the support of an adult. So that's what kind of everything is focused on. And I think there's good evidence for that. But I do think we're going to see, obviously, people who don't fit into any of the groups, or at a particular time don't. Okay. Okay, so are you still with me? Doing okay? All right. Okay, so we're going to I have no idea how long it's been. Oh, I have 7 minutes. Wow. Really? 10? Okay. I just bought myself 3 minutes. I better hurry up. All right. Okay, so what types of evidence do we have and what do we need? We have a call to action. Okay? We have been asked to step up, and it is clear. It is a loud, clear call to action. We have an organizing framework that integrates scientific and practical knowledge gathered from several different lines of research by people who know what they're doing. And we have enough information to do something now. Okay? That's what we have. We have a body of longitudinal association studies linking early experiences to later health and well-being. We have compelling animal models of how exactly this could happen. What is all the steps in the pathway? So you have a challenge, and then what behaviors happen, and then what changes physiologically. What are the downstream effects of that? How does that lead to poor health? We have animal models that at least make a case for how that could work. And we have a lot of short-term, what I think of as process linkage studies, where we show a piece of the puzzle with kids, right? We don't have the whole thing, but we've got a piece of the puzzle. And we have some promising interventions. If it really is about a supportive caregiver, well, we know how to do something about that. The great example longitudinal study is the ACEs studies. That's why we all talk about ACEs. Collaboration between the CDC and Kaiser, 17,000 participants. You can compute your ACE score online if you're curious. Basically, you get a measure of your own early life adversity. 6 or more early life adverse experiences associated with a 20-year reduction in lifespan. Nothing touches that. What touches that? What health risk behavior touches that? Anything? 20 years? Nothing. Okay? This is no joke. 4 or more is associated with a number of health conditions. And this is your own early life experience. So one of the things we struggle with when we study kids who are 0 to 3 is whose do we measure? It's good to measure the kids, but it's tricky because you're not, what are you asking if they're abused and neglected? So where are you going to go with that? And then it may actually be really informative to know what mom is working with. It may be really helpful to know what mom has already been through, because then it'll tell you what kinds of supports mom might need. All right, I'm not going to go through this compelling animal model because I don't think I have enough time, and it's complicated, but you'll just have to trust me that this model goes all the way through to exactly what happens epigenetically across generations. And I am going to make sure to tell you about epigenetics, even if Jody comes over here and starts hitting me with a stick, because I know you want to know that, and I don't want to leave that out. Are they going to be able to get this version of the slides? They are? Okay, so you can read this yourself. It'll be a little complicated, but basically it's the story. How did we end up with this compelling animal model? It tells you the story of what happened all the way through. Cross-fostering the pups so that they're not with the genetic mom, all the different steps that they did to isolate exactly what was going on, and figure out how is this happening. Okay, so we're going to go all the way through, and then you're just going to have to believe me, caregiving was the critical variable. What kind of caregiving did they get? So the pups who had the high caregiving moms had the good outcomes when they were stressed, even if that was not their genetic mom. And then they grow up to be that kind of mom themselves. Well, how does that happen? It's not genetic. We just determined it wasn't genetic. It's not my mom. It happens by an epigenetic mechanism that has been explicated. Okay? All right, and then this is just the data I was telling you about before. These are our kids in Denver. This is what the difference looks like between the low reactive kids and the regular kids. You can see that there's no overlap. They're not the same kids. I mean, the attenuated kids, the kids with the flat pattern, don't even touch the other kids. And they already have early signs of depression, which fits this physiologic learned helplessness profile. So that's just some data from my lab. Okay, what do we need? We need longitudinal studies with families that begin prenatally and actually follow them to help outcomes. It's hard to get an investment in that kind of work. There are some studies that could be used, but the problem is they don't have the appropriate physiologic, behavioral, cognitive, and neural assessments. They have some of those pieces, but not all of them. And we need all of those pieces, because that's the story we think is going on. And we need to know, sometimes the studies that have great physiology, they don't talk to the people, right? We need to talk to people and understand what happened, what's happening in their lives, in addition to imaging their brains, right? We need both pieces, and that's going to take collaborative teams to get that done. So that's something that people are actively working on, trying to better characterize the components of toxic versus tolerable stress, to shed more light on the idea of risk and resilience. And what we want are screening procedures that vary in depth and by context. We need quick screeners that you can get in your pediatrician exam. We need in-depth screeners for kids who come up in different situations. We need screeners for social workers. We need screeners for teachers. We need to catch these kids. So, and that's all stuff that could be done. We need to test interventions, and we need to work on prevention, because nobody wants to end up in this state with their kids. Okay, so maybe we start prenatally and we start giving them the psychoeducational tools they need before the child is born and is overwhelming. All right, risk and resilience. It sounds like a deterministic story. It's not. Okay, social and biological risk is not deterministic. Some individuals with fewer risk factors develop stress-related illness. Some individuals with many risk factors do not. Risk factors and resilience factors are each other's opposites. So the same thing that gives you a boost in one situation also takes away in another situation. Easy temperament, difficult temperament. High IQ, low IQ. Maternal psychopathology, good maternal health. They're all kind of the flip of each other, and they add up. And note that as much as we love a pull yourself up by your bootstrap model in this country, nobody is immune. If you add it up, everybody's going to take a hit. They're just going to, they may take it a different way, but they're going to take it somehow. And, yeah. Yeah, so there's some research on that so that kids are able to sort of make microenvironments for themselves. So say you live in a very difficult, urban environment, but you're a high IQ kid, you can get in a special track program, you can get resources devoted to you because you have this special trait. Or you're really good at basketball, or you're really good, right? It's that idea, that you have something that gives you resources that other people can't get.
Okay, not that the physiology
Right. Right. I mean, there is a little bit of research on giftedness and physiology, but it's mostly in the risk category, actually. So gifted kids have some liabilities in that domain. Yes, they can be. They can be. Okay. The critical thing here, and this is not something that escaped Shonkoff and Boyce and McEwen, is that across decades of research, the most powerful resilience factor is one consistent supportive adult. Okay, and we have all these mentoring programs and all these help youth programs. That's actually not going to do it because it's 3 months or it's a year and you go away and you don't. They need a consistent adult across their lifespan. They need somebody to invest in them. All right, intergenerational effects. So, okay, we all know about the sociocultural intergenerational effects, the increasing, I got it, I'm going to make it. The increasing income disparities that are making it harder and harder for families. And also, we learn how to parent from our parents and our grandparents. We learn how to do these things, because how else would you learn? You can't read that out of a book. All right, we're going to do epigenetics, even if she hits me with a stick. Okay. So you inherit your genes, everybody knows that, right? You get your DNA from your two parents, it gets combined into this unique thing, and you have your novel configuration, and that's you. And that could be the whole story. But of course, DNA does not equal behavior, it does not equal disease, right? It equals proteins. And it doesn't even equal proteins all by itself. Somebody has to tell which cell to turn on, which gene to copy, when, where, and how. Right? Otherwise, your heart cells and your brain cells would all be the same. Something tells which genes to turn on when. Okay? And that direction, that set of directions about when to turn things on, happens because genes get marked. They get marked for activation or inactivation, and collectively that process is called epigenetics. So it's telling which genes, which ones to turn on and when, or which ones not to turn on. Now, some of that happens transiently. It isn't a very long process, and some of it can be inherited. So some markers, particularly the ones we're interested in, can tell the individual, okay, this is a high-stress environment. Let's upregulate or downregulate these genes, and it might be good for your offspring to do that too. And there is some evidence for some epigenetic mechanisms that continue as long as 3 to 4 generations. They are controlled and sensitive to illness, stress, toxin exposure. So there's a lot we're going to learn about pollutants and that kind of thing in terms of how, especially related to cancers and those kinds of outcomes. So you could inherit not just a risky genetic profile, but a risky epigenetic profile. Okay? It should be more changeable, but it's another set of directions that your brain and body are getting. Okay? And there's so much more going to be learned about that in the next decade. It's a super, super, super active area of research. Okay. Well, I won't make any concluding remarks since I'm out of time, but that's okay. I think you've heard